One of the main advantages of ultra-wideband is that it gets us out of the roadbed when it comes to wayside equipment. All of the UWB equipment that we've installed here on the 7 line is actually on the wayside, and that makes it easier for us to deploy, makes it faster, it saves on cost, and most importantly, it's easier to maintain, which translates into fewer disruptions for riders, getting them where they need to go every day. What we're demonstrating today is how we are now fully integrated with communication-based train control. And that's the system that manages the flow of trains on the subways, letting them run closer together and delivering a better service for riders. And what we're going to do a demonstration of is how we can remotely set up a work zone and give train operators, and especially work train operators, information about when they're about to enter a work zone, when they can proceed through it, and when they can resume normal movement authority. So Tim, can you create a small one, because we want to get back quickly, maybe a 100-foot work zone and then zoom in on it? So what we're choosing here are the wayside information parts, and we're letting the system create a work zone so that the train operator will know exactly where it goes. So go ahead and save that, Tim. So right here we have information about where the zone begins. The actual work zone is going to be represented in the blue, and the green dot is going to be the place where the train can resume normal movement authority. Notice that we're going to be able to know exactly how many feet we are from that work zone as the train is moving through, or the work car is moving through. So why don't we go ahead and resume? We'll head back. In this run, we're actually going to do it under a manual control. And the idea here is that the operator would be able to get these signals as part of a heads-up display and use the information to navigate safely through the system. So this screen on this side is a representation of what the train operator will actually have, and you'll notice that they're in a green safe area.
Work zone ahead, prepare to stop.
So at that point, the operator gets a notification that they're approaching a work zone, and they've got to operate safely under 10 miles an hour until they reach the point of the work zone, and at that point they're going to get information and told that to stop.
Entering work zone, stop now.
Okay, so right now they've entered a part of the work zone and they're told to stop, and the reason is if there's work ahead, there's actually going to be a trip that stops the train. So the operator will stop far in advance of that, and what we've developed is actually a handheld device so that the workers have an opportunity to communicate directly with the train operator, letting them know when they can release the train and get it back into movement. This is a big step because the trackside worker would have an understanding of making sure that everybody was cleared up, and by sending the all clear signal into the device,
work zone is clear, proceed with caution.
We can now proceed under caution through the work zone and eventually resume full movement authority. Moving dot here represents the rear of the train. As soon as that clears the work zone by the appropriate amount, the train will get a notification that it can resume and it will proceed normally.
Resume normal operation.
I'd just like to finish with saying that, you've seen quite a lot of technology there in the presentation, but the proof of the pudding is the fact that in the middle of March we started with nothing. We just awarded the contract, and in 9 months everything has been developed, tested, installed, and we've seen some side benefits. This demonstration of which wasn't in the schedule. It's an additional function that this technology is capable of, and we look forward to a lot more of that as we go forward.